Hello everybody. Today we're going to be talking about series circuits. So you might ask the question, what is a series circuit? Well, it's quite simply when two or more resistors appear without a junction in between, they're considered in series. So we take a look at this circuit to the right here. We have a 9-volt battery, and if you travel along one wire, you're going to meet the first resistor R1, R2, and R3. There's nothing in between each resistor. You can travel directly between each one without branching off. So the current would do the same. These are considered to be in series. So R1, R2, and R3 appear in series with one another. Along came this guy named Kirchhoff, and he's pretty much the Lord and Savior for everything circuit related. And he came up with this idea, or he discovered this series law, which is called Kirchhoff's series law. And that states that the current I across each resistor in series is equal. Okay, so if you take a look at this 9-volt battery, reaching out from the positive terminal of the battery, the current's going to travel along here, and it's going to meet the first resistor. It's going to have some current I1, and it's going to pass through down towards R2, and that's going to have some current I2, and it's going to pass down through here. It's going to meet this resistor and have a current I3 before finally terminating back on the battery. Now, the thing about I1, I2, and I3, this is all about moving charge. That's what a current is. It's moving electrons. Now, if this current on each of these resistors was different, then there'd be a pileup of charge on one end of the resistor, and only a few would trickle through. And they'd be going through at varying rates, okay? And eventually, all the charge would pile up on the biggest resistor. Now, the great thing about Kirchhoff's series law is it states this. It states that I1 is equal to I2 is equal to I3, and this goes on forever depending on how many resistors that are in the series circuit. Now, the other law that was discovered was Kirchhoff's loop law. Kirchhoff's loop law says this. If you have a 9-volt battery, when a current is traveling across the resistor is going to use some of that energy or some of the potential. So if you have a 9-volt battery, well, there's going to be some energy lost across this resistor. So that says the voltage is going to decrease. Over here, the voltage is going to decrease, and down here, the voltage is going to decrease across R1, R2, and R3. But Kirchhoff's loop law says that the voltages, V1, V2, and V3, they're all going to be equal to the total voltage, or the voltage from the battery. In other words, the change in potential is going to be equal to 0 volts. So we're going to use these two ideas in order to take a look at a circuit. So here we have a question that says complete the table for the following circuit, and there's a nice cute picture of a snail there. And we're given a series circuit. We know it's a series circuit because we have a battery followed by a lamp, a lamp, a lamp. Now a lamp turns electrical energy into light energy, but it can be treated like a resistor, where resistors convert electrical energy into heat energy. Taking a look strictly at this table, we see that the battery is going to have 24 volts. So let's write that down on our diagram right here. And we also know that lamp 1 has a current of 2 amps across it. So I1 is equal to 2 amps. Well, because of Kirchhoff's series law, we know that the current across the battery is going to equal the current across number 1, current across number 2, current across number 3. So straight away, we can fill out this entire column of the table. We're going to say that's 2 amps, 2 amps, and 2 amps. Okay, and this is going to be Kirchhoff's series law. Great, so we've got almost all the table filled out already. The next thing that we should be looking for is Ohm's law. Ohm's law is the saving grace of most things circuit, and if you remember, Ohm's law states this. Ohm's law states that the voltage across any resistor is going to equal to the current times the resistance. Well, if we know V or I, then we can find R, or if we know any of these 3, we can find the missing one. If we take a look at lamp number 1, we have the current and the resistance, so we can find the voltage V1. So if we take a look at lamp number 1, we can say that V equals I1 R1, which is going to equal 2 amps times 4 ohms, which means that the voltage across number 1 is going to be 8 volts. And we can write that right in our table. This is going to be useful because we can start using Kirchhoff's loop law now. If you remember, Kirchhoff's loop law says that the change in potential across the entire loop is going to be equal to 0. Or in other words, for lamp number 3, we can say that 24 volts, or the voltage of the battery, is going to equal the voltage across number 1 plus the voltage across number 2 plus the voltage across number 3. 24 volts is going to equal, well, voltage 1 is 8, voltage 2 is going to be 6, and voltage 3 is our unknown. So we can combine these two, and we can find that 10 volts is equal to the voltage across number 3, and that's what we can write here. Great, now look at this. We have two things in each of these columns, and we're looking for the resistance. We're back to Ohm's law. Ohm's law is going to help us find out the remaining information. For lamp number 1, go back to lamp number 1, we can say that, well, from Ohm's law, we have V equals IR. Therefore, R is equal to V over I. So the voltage across lamp number 1 is, or sorry, this is going to be lamp number 2. The voltage across lamp number 2 is going to be 6 volts, and the current is going to be 2 amps. Therefore, the resistance is going to be 3 ohms. We can write that right there. If we take a look at lamp number 3, well, the resistance in lamp number 3 is going to equal the voltage across 3 divided by the current across number 3. So that's going to be 10 volts divided by 2 amps, which will be 5 ohms. And then finally, we can go right back to the battery. And with the battery, we can say that the resistance of the battery is going to equal the voltage across the battery divided by the current across the battery, which is going to be 24 volts divided by 2 amps. And that's going to leave us with 12 ohms resistance in the battery. So that's all the information for series circuits. Stay tuned for more information about parallel circuits.